Alright, quiet down, bring it back up front, please. So the first example here, two-column proof, although half of it has been done for you. Lucky guys. So we only had to fill in our reasons on the side. Now, this is one where they gave us lines parallel, but then we're trying to prove a different set of lines. So what is our very first step there? Given! Woohoo! It's nice and easy. Alright, so they gave us that L is parallel to M. And we already have those markings drawn in there. I'm just going to draw them bigger. Alright. And they also gave us that angle 1 is congruent to angle 2. Now, as it stands, do 1 and 2 have any particular type of special relationship? No. They're not even on the same transversal. And they're not even on the same parallel line. So no special relationship there. We just were given that information. Okay, so we're trying to show that A and B are parallel. Now, in order to show that A and B are parallel, we need to have one of those special angle relationships. If I try to use, so in trying to show A and B are parallel, if I try to use this blue transversal, notice that we only have one angle to work with. Nothing else is, no other angles are numbered on that, along that transversal. So we can't get any type of special relationship because we only have one angle to work with. Whereas if we try using this line, we see that we do have a relationship between 3 and 2. What type of relationship does 3 and 2 have? Alternate exterior. Now, as it stands, we can't say they're congruent because we don't know that those lines are parallel. But if I can show those are congruent, then I can say the lines are parallel. Okay, so that's kind of where we're aiming. Alright, so again, we have 1 and 2 are congruent. And they gave us that these lines are parallel. Alright, how do I know that angle 1 and angle 3 are congruent? Go ahead, Mike.
Corresponding angles postulate.
Good, corresponding angles postulate. Do we agree? Alright, corresponding, oh, I should have abbreviated. Angles postulate. So our corresponding angles postulate says 2 parallel lines, transversal cutting through it, corresponding angles are congruent. Very good. A is my transversal. Now, how do I know that 1 and 2 are congruent? Given, yeah, very good. They split up our given here. Okay. Now, step 4 says that 2 and 3 are congruent. I can see that from my picture because I've marked in all my extra markings, but how do I know that I can connect 2 and 3? Come on. Good. Transitive or substitution property. Be careful. We cannot say alternate exterior angles theorem. Why can I not say that? Cameron?
Because you can't prove that it doesn't. You don't know that A and B is parallel yet.
Right. We don't know that they're parallel yet. That's what we're trying to show. Good. So I can't use alternate exterior angle theorem because I don't know they're parallel. I'm trying to show that they're good. So we see 3 is congruent to 1, which is congruent to 2, so 3 is congruent to 2. So transitive. Again, you could have put substitution have been fine. Alright, so now what lets me say that line A is parallel to line B?
Converse of alternate exterior angles theorem.
Good, and so that's when our alternate exterior angles come into play, but we need to have that word converse in front because we're showing parallel. So converse of alternate exterior angles theorem. 10 minutes later, we're done writing this down. Okay, questions on that, please?
You have to put the given later. Can you say
If you were doing this on your own, you could have just gone ahead and stated them both. Personally, I like to just state everything at the beginning so I don't forget to put it in. Yeah. Good question. Other questions on this? Yes.
Number 4 be vertical angles?
2 and 3 are not vertical angles. They have to be, if it was right here, that and 3 are vertical angles. but 2 and 3 aren't even along the same ray. So vertical angles, the definition says 2 angles whose sides form opposite rays. So if I look here, my rays for angle 2, here my rays for angle 3, they don't even share or go opposite from each other. So they're not vertical angles. Other questions on this group? Yes.
There are general call-outs.
That's the relationship between 2 and 3 here. So if let's go ahead and re-isolate this. So A and B, line F. So if I look here, 3 is on the outside, 2 is also on the outside, it's on the exterior. They're on opposite sides of my transversal, so they're alternate exterior angles along lines A, B, and F. Does that make sense? Other questions or questions? No. Alright, so today what we're doing is just more practice with those theorems and postulates and vocab that we've been learning in the form of proofs. Like I said, we have proofs every single unit. There's nothing new about how I do proofs, just new information that I can use in my proofs. So let's take a look at that postulates and theorems page. We've learned these, except the bottom one, but we've only transferred some of them over. So I think I told you to go and transfer these over, so let's just double check that we have the correct ones there. So reminder that if I have two parallel lines cut by a transversal, and I have corresponding angles are congruent, that's my corresponding angles postulate. Alternate interior angles are congruent, that's my alternate interior angles here. And same side interior angles are supplementary. That's my same side interior angles there. And finally, alternate angles are congruent. Now, we then said our converses are going the other way. So converse of the converse of corresponding says, if two lines and a transversal form congruent corresponding angles, then the lines are parallel. So again, converse is not just a type of shoe. This is what allows me to prove that lines are parallel. So I am given the special angle relationship is congruent or supplementary, then I can say my lines are parallel. All right. What's another one of these? We have congruent corresponding angles. What's another one? Good. Congruent alternate interior. Alternate interior angles. Then that means lines are parallel. What else do we have? Good. Same side supplementary. So let's see. Two lines transversal form. Supplementary. Same side or consecutive. Interior angles. Then the two lines are parallel. And what's my? Whoa! Why did I write that down there? Sorry, guys. What's my last one? Good. If I have alternate exterior angles, what do they need to be? Congruent alt x angles. If I have congruent alternate exterior angles, then the lines are parallel. Good. So that's what we learned 2 classes ago. It's just the converse means that we can prove the lines are parallel. Then last class, we talked about how using algebra, I can determine if lines are parallel or perpendicular. But then we also had 2 additional theorems in geometry. So these two, if 2 lines are parallel to the same line, then what do we know? Good, then those 2 lines are parallel. The two lines are parallel. And if 2 lines are perpendicular to the same line, then what do we know? Those 2 lines are parallel. Nothing except there. And the 2 lines are parallel. Okay? And again, that makes sense if I have parallel lines. These are parallel to this, and this is parallel to that, and these are parallel. And if 2 lines are perpendicular to the same line, This is perpendicular. This is perpendicular. And these must be parallel. That's all that's saying. Now we do have one more that we haven't learned yet, the perpendicular transversal theorem. It's got a fun and exciting name, and we're going to come back to that in a few minutes. So keep that in your back. So these are our new postulates and theorems, and of course you have your vocab page as well, of all of our new information for Unit 3 that we can use for these proofs. So let's go back to our proofs. And start off with a couple simple ones. You guys did well with example 1. Let's take a look at example 2 and example 3. Now example 3 here, we actually already talked about this last class. We just kind of talked about in general. We didn't actually go through and prove it. So today we're actually going to prove it. If we notice for 3 here, it says, given that M is perpendicular to L, and N is perpendicular to L, show that those are parallel. Well, that's two lines perpendicular to the same line. We know those two lines are parallel. That's the theorem we just wrote down. So we're proving that theorem today. But remember, we can't use it if we're proving it. All right, so example 2, not too bad. I want you guys to go and try that on your own real quick. I'm going to bring back the postulates and theorems page for you if you need.
Same thing we did. Right angles is not.
I know, but like, isn't there right?
I think that was supposed to be last class.
It's the same
That's what I
thing.
thought.
No,
I had to like stretch it out.
Okay, so we've got
no, but the way it works,
this was
it says pronunciation that means or right angles. But if you're proving it's
How many steps do we have?
4, 5.
Ooh, 3, 4, and 5. I'm going to give you 30 more seconds for those of you that are still working on it. Very good. I'm sorry, what did you say? Yeah, it's not too bad.
It just means the right one step.
Alright, let's take a look at example 2 here. I think I had 4 steps. Let's see. So we have L is parallel to M, and they've already marked that in for us. I'm just going to draw it bigger to kind of emphasize it. And 1 is congruent to 2. Do 1 and 2 currently have any special angle relationship? Nope. Okay, so we're going to have to connect something to 2 there, probably. All right. Other statements. Other reasons. Wait for the smartboard to come back to us. All right. So L is parallel to M. And we have angle 1 is congruent to angle 2. That is given. Raise your hand if you got the first step right. Cameron, did we get the first step right?
Oh, yeah.
Oh, good. That's fine if you split in 2 steps. That's good. Okay. Now, what did you guys do first? Teresa?
I said angle 1 is congruent to angle 2.
Angle on one. Man, they were so hard.
Oh my god.
Teresa, feel free to yell at them next time they get something.
Yeah.
Slightly off. Alright, so angle 1 is congruent to angle 3. Ooh, man, tough crowd out there. So 1 is congruent to 3, and we know that by the corresponding angles postulate. Good. Now, remember, we were given L and M were parallel, and A is my transversal there. They both sit along there, so that's why I can go ahead and use this. Sam, did you have a question? Or you want to say the next step?
No.
You're good?
Yeah.
Okay. Okay. What do we do next from here? Lucy?
Angle 3 is congruent to angle 2 because of substitution.
Very good.
Good job, Lucy.
Angle 2 is congruent to angle 3 by substitution or transitive. Now be careful that you did not fall into the trap of saying by corresponding angles.
I did.
Yeah, so we have to be careful. It's an easy trap to fall into, but I don't know that A and B are parallel. I'm trying to show that they are parallel. Okay? So just double check to make sure that your line's parallel before you try using that. So we have transitive property or substitution property would have worked. Alright, on Kit.
And then I had A is parallel to B because of the converse of corresponding angles postulate.
Good, so those of you that tried using corresponding, that's actually your next step here. So because, if we look here, A and B, 3 and 2 both sit along transversal M. So they are corresponding angles. We know that to be true. Since my corresponding angles are congruent, then I can say that A and B are parallel. Okay. So that is converse of corresponding angles postulate. And we must have that converse. Converse of corresponding angles postulate. Because converse is what we use when we're showing parallel. Questions on that? Raise your hand if you got that one completely right. Well done, very good.
Who's writing? You're on
It's fine. I won't be that picky with it. You're good. You can raise your hand. Okay, now let's take a look at number 3. Again, this is a theorem we know to be true. We learned this last class, but we are proving it. So we cannot use the theorem to prove it. We cannot have just a two-step proof here. Alright, it says given M is perpendicular to L, and N is perpendicular to L, prove that M and N are parallel. Now, they've already marked into the picture for us that this is indeed perpendicular, with that marking there, and indeed perpendicular. Now, notice that they labeled angles 1 and 2. Those are the only ones that they labeled, so those are probably going to be the only ones that we are going to use. If it's not labeled, you're probably not supposed to use it. There's a hint there. But I will say, so far they've been nice in only labeling the angles we need. Sometimes they'll label all of it, and then you have to choose which angles you use. Okay, so just be careful with that. All right, so let's go ahead and start off with this. M is perpendicular to L, and N is perpendicular to L. That is my given. Now, what type of relationship are angles 1 and 2? Corresponding. I can't say that they're congruent because I'm trying to show those lines parallel. We don't know that they're parallel, but we do know they're corresponding. So if I can show that those are congruent, then I can say the lines are parallel. So let's aim for that. Now, we don't really have any other information given to us other than the fact that these are perpendicular. So the only thing we can work with right now is perpendicular. So what can I say? If M is perpendicular to L and N is perpendicular to L, what can I say? What is the definition of perpendicular lines to L?
That forms 90 right angles.
It forms right angles. Good. So we've got perpendicular lines form right angles, okay? So remember that was our definition we wrote at the top of our notes last time. Pull it up. This one, I think. So definition of perpendicular lines tells us two lines that meet to form right angles. And we know it's going to form four of them. Here we are. Two lines that intersect to form right angles. Now it's extremely important you recognize it says that we form right angles. It doesn't say anything about 90 degrees. Okay, just that they're right angles. Sandra, do you have a question? Okay. All right. So when we see that they're perpendicular, we can say that all of these are right angles. Now, since we're trying to get to 1 and 2, let's just stick with 1 and 2. So angle 1 is a right angle. Angle 2 is a right angle. And how did I know that, Amani? Oh, you have a question? Yes.
Why do you have to just
Do you know it's 90 degrees? How do you know it's 90 degrees?
What's the right angle?
How do you know it's a right angle? Because they're perpendicular. All we have right now is they're perpendicular, so we have to build to that. So the only thing perpendicular tells me,
So is our next step going to be this right angle?
we could do that. Well, you mean the 90 degrees? Yes, we can go that way. It's actually going to be a little bit longer than another method we could take, but your next step would be measure of angle 1 equals 90 degrees, measure of angle 2 equals 2 degrees. Lucy?
Didn't you say that one is
These have the squares, right?
You said angle 1 and angle 2.
These have, this is angle 1, that's angle 2. Yeah, but do be careful because we only have this marking because it's perpendicular, so we still have to work with the fact that it's perpendicular. Does that make sense then? Come on.
Doesn't that sign also mean 90 degrees? So since it has that sign, you can just say it's 90 degrees because of that?
But again, we know that because it's perpendicular, but also this is angle 1 and this is angle 2. They didn't put that marking on angle 1 and angle 2.
They do like
What is it?
definition
It's
something
like can you use like linear pairs and say like the measure of angle 1 plus 90 since you have that symbol there equals
Yeah.
180?
If you want to go down that road, you could say angle 1, and we would then have to label these angles, which again, if it's not labeled, you probably don't need to use it. But we would have to go in and label, and we would say angle 1 and angle 3 are linear pairs. Angle 1 and angle 3 are supplementary because linear pairs are supplementary. Measure of angle 3 is 90 degrees by definition of right angle. Measure of angle 1 plus 90 degrees equals 180. Subtract and we get measure of angle 1 equals 90 degrees. You could definitely go down that road. It's just obviously going to take a lot longer, right? Is that what you were saying with that, Jalen? Yeah. So guys, we know that these are right angles because it's perpendicular, and we know right angles means 90 degrees. But we can't just go from perpendicular straight to 90 degrees. We have to build up to it. Just like we know that linear pairs are supplementary, which means they add up to be 180, but we have to build up to that. The linear pair postulate tells me supplementary. Definition supplementary tells me 180 degrees. So similar thing here. Perpendicular only tells me that they're right angles. Then I can use the definition of right angles to say that their measures are 90. Do we see that difference there? We're really particular with this in geometry. Other questions before we move on? Okay. Now we could travel down the road of saying, don't write this down, but we could go ahead and say measure of angle 1 equals 90, measure of angle 2 equals 90, and that's by definition of right angles. And then we could say that measure of angle 1 equals measure of angle 2. What would be my reasoning there? Yeah, transitive or substitution. And then I could say angle 1 is congruent to angle 2. What would be my reasoning for that? Definition of congruent angles. But there's actually a faster way to go from here to there. So you can definitely travel down this road. Just takes a little while. But we actually have something that lets us go from stating 1 is a right angle and 2 is a right angle to stating that they're congruent. So hold that thought. We didn't actually fill in the reason here. What's my reason for step 2? Good. Definition of perpendicular lines. Because they're perpendicular, I can stay at the right angles. Okay, so again, we could go down this longer road, but there is a way to, for my next step, that angle 1 is congruent to angle 2. I want you to talk with your shoulder partner and see if you guys can remember. Hint is from Unit 1. So see if you can remember what would allow me to say to jump straight to angle 1 is congruent to angle 2.
Oh, instead of doing the definition at right angles, right angles are equal to right angles.
Oh, I'm not talking about
All right, let's see what we came up with. Does anyone feel confident with what they think it is? Lucy?
The right angles congruent.
Does that sound familiar? You learned it, I promise you. Right angle congruent theorem. Right angle congruence theorem. Right angle congruence theorem. What does the right angle congruence theorem tell us? All right angles are congruent. Sounds like common sense, but that's what tells us that. Let's see if I can find where we did it.
So then you can just state that they're parallel, right?
Then we can state that they're parallel, yeah. Was it in here? You got it. You got it. Alright, so right angle congruence theorem. If you happen to forget that title, you can just say all right angles are congruent, which honestly is about the same length as the title. Raise your hand if you remembered that. And did you say it?
What?
I thought I heard you say it. They were close. Very good for those who remembered it. Okay. So now that I have angle 1 and angle 2 are congruent, now can I say my lines are parallel? Why? I hear converse. Pretty sure the word of came next. Postulate. Good. Converse corresponding angles postulate. Very good. They are corresponding angles. Now that we know they're congruent, now we can say the lines are parallel. Very good. Alright, questions on that one? So the front side, not too bad. Oh, what's this? Unit 1, Lesson 3 notes. Gee, it looks like we did the right angle congruence theorem. All right angles are congruent. I did teach you stuff. That's when it was. That was a while ago. That was September 6th. What? This guy? Alright. Okay, so now let's take a look at the back side. Now we're getting to something a little bit trickier. Not so straightforward. Before we get to the back side though, I want to go ahead and let's talk about that perpendicular transversal theorem on our theorems and postulates. The last theorem to learn this unit. Just for this unit, there's so many more to learn for the year. We have postulates and theorems every single unit. We have a lot in the unit. I think we have more than 50 to learn for the year. We've already learned like 20. Alright, our perpendicular transversal theorem, again, is going to seem like common sense, just like 5 and 6 did. And it's kind of similar to our 6th theorem here, okay? Now this one actually has a title. That's exciting. A weird one. So perpendicular transversal theorem. So it has to do with perpendicular and a transversal. Alright, if a line is perpendicular to one of two parallel lines, if a line is perpendicular to one of two parallel lines, so we've got our conditional statement here. Let's go ahead and investigate that hypothesis and see if we can come up with a conclusion on our own. All right. So I have, it says two parallel lines. And Sydney, give me a letter. C. C. Wonderful. It's not going to be another one. G. All right, we've got lines C and G. So we've got our two parallel lines. And it says a line is perpendicular to one of those. Gloria, give me another letter. P? Sounds good. Okay. So my conditional, the hypothesis says a line is perpendicular to one of two parallel lines. Do you agree that our picture meets that criteria? Okay. So for our example here, if P is perpendicular to C, and we also have C is parallel to G, right? So P is perpendicular to C, and C and G are parallel. Okay, then I want you to talk with the person behind / in front of you. What do you think your conclusion would be? It's a relationship between P and G. All right, bring it back up front. What do we think? P and G, what's the relationship? Perpendicular, very good. Why?
Because it's a straight line.
Give me more. Say that louder and more information.
Corresponding to right angles.
Yeah, these are corresponding angles. I already have the lines are parallel, right? So what do we know about corresponding angles of parallel lines? Gotta be congruent. So that means this must also be the same measure. Perpendicular lines meet at 90 degrees. 90 degrees are the same, then that's also right angle. Okay. Okay, so if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other line. Or the other parallel line, if you would. The other parallel line. Okay, so that's your perpendicular transversal there. Basically, your perpendicular line is the transversal. So if it's perpendicular to one, it must be perpendicular of parallel lines. Amani, what was your question?
So instead of using the corresponding postulate,
Yeah, if you're given this situation, what you want to look for is a situation where you have a set of parallel lines, and you know one of those lines is perpendicular to it. We can immediately jump to that rather than having to use corresponding angles and right angle definition and all that jazz. Okay, questions on this? Okay, our last theorem for Unit 2.
Forever?
Unit 2. I mean Unit 3. Oh, we're Unit 3. Unit 3.
Huh?
No, we have so many more to learn. Okay, let's go ahead and go back to our notes here.
2 minutes.
How many what? Units. 10 or 11? Oh my god.
What the? 2.
Yeah, 10 or 11.
It doesn't matter. It's on.
Alright, example 4.
3 for 4.
Go ahead and read over that real quick to get yourself familiar with it.
We were.
Alright, It says given line segment AU is perpendicular to segment QU, and angle 1 is congruent to angle 2. Alright, so segment AU is perpendicular to QU, and we have angle 1 is congruent to angle 2. I'm going to go ahead and write that out. Mark the markings on my picture to help me visualize it. Alright, what they want us to do is prove that DQ and QU are perpendicular as well. So we want to show this. Now, we do have a couple of ways we can get there. But if we can show, we've got a couple of options. If we can show that this, well, first of all, those are perpendicular, that's obviously great. If I can show that this is a 90 degrees or a right angle, we can do that. But did they give me any measures of my angles in here? No. And although I could state that this one is 90 degrees, I don't have anything about measure of angle 2, measure of angle 1, so it's probably not the route we want to go down. We probably don't want to say something about this be 90 degrees. You could. There is a method in which you could use that. But we might want to say something about right angles. If you can get those 90 degrees, you can do that, or perpendicular. So, taking a look at our picture, from that information there, what else can I draw from there? What else can I pull from this?
QD is parallel to UA.
Ooh, QD is parallel to UA. Discuss with your shoulder partner if you agree, and if so, why? Do you agree, and why? Alright, let's see what we think. First of all, raise your hand if you agree. Raise your hand if you think that's a crazy outlandish statement. Alright, QD is indeed parallel to UA. Why? Who has a great reason for this?
The converse of alternate interior angles.
Ooh, converse of alternate interior angles theorem. Raise your hand if you think that is true. Alright, Alexandra, what angles are we using to choose, or to be able to say that? What are my alternate interior angles?
Angles 1 and 2.
Yeah, angles 1 and 2. If I look, here are my lines that I'm saying are parallel. Would you agree this would be your transverse?
Yes.
So 1 and 2 are indeed alternate interior angles. We were given that they are congruent, so we can go ahead and say by the converse that those lines are parallel. Good. So converse of alternate interior angles theorem. Forever long time. Good. Alright, now from here, we have a couple of routes we can take. Okay? So I want you to now talk with someone nearby you, pick whether it's next to you, behind you, or in front of you, as to what we can do next. How can we go from here to our final proof statement, whether it's a few steps or just one step, what can we do? We should have a separate statement because purpose may to make sure you get
Are we done in like one step?
Yeah, one more step. Jalen's skeptical of you, but I say it can be done.
We're done.
I'm done. I'm finished. What do you want to do?
Okay, now a couple of you have asked me this. Can we write AU instead of UA? most certainly. I am not super picky on this. What I'm picky about is that your proof statement matches perfectly and your given statement matches perfectly. If the letters move ordered throughout the proof, that's fine by me. If you don't like that, you can definitely switch it. No big deal. But make sure your proof statement says DQ, not QD, and QU, not QQ. All right. What are your thoughts, Alexander?
I think you just need to add that DQ is perpendicular to QU because it's perpendicular transversal.
Ooh, so she wants to use her new theorem. Go ahead and in our last step, claim the proven statement. Ooh, let's take a look at it.
That's a go.
DQ is perpendicular to QU, and you said because of the perpendicular transversal theorem. Let's take a look at it. This transversal. So if we treat this as my transversal, hey, we have it's perpendicular to one of my, right, we said it was parallel, we just proved that. So if it's perpendicular to one of my parallel lines, do you agree then that it has to be perpendicular to the other parallel line? Yeah, that's what my perpendicular transversal theorem says. Very good. So we can actually knock this out with just one more step by the perpendicular, you know what, let's shorten that, because the title's long enough as it is, transversal theorem. Raise your hand if you managed to think of that way. Very good. So that is definitely the shortest and quickest way to get there. That is valid. That was great. But say we did not do that. We have other ways we can get there. Those of us that did not use perpendicular transversal theorem, what were our thoughts? What did we do? We just thought. Okay.
I don't think this works, but I thought you could substitute because DQ is parallel to AU, and in the first statement it says AU is perpendicular to QU, so that you can substitute AU.
You gotta be careful. We don't have substitution works with like perpendicular like that in parallel lines, but we do have that's true because of perpendicular transversal theorem. So you have the right statement, just your reasoning wouldn't be wrong. Yeah, that's good thinking though. Other thoughts? Did we do anything else? Anybody do same side interior angles? No one?
How would that have even worked?
Well, let's take a look. I'm so glad you asked, Sam. These are my parallel lines. Now, this would definitely take longer to get there, but since this is perpendicular, can we say that QUA is a right angle? QUA
But how would we know that?
is a right angle. How would we know that? That's perpendicular, so by definition of perpendicular lines, since this is perpendicular, we can say that this is a right angle. Definition.
But how do you know it's perpendicular?
They gave it to us. But no, you're asking the right questions, because when I go through your guys' proofs and you say something outlandish, I go, how do you know that? Okay, how did you know that? I do go back and follow to make sure you have the right thinking. That's good. All right, so we could have said QUA is a right angle. And then since we show that these are parallel, we could say that angle, so with the fact that angle Q here, now I'm allowed to call this one just angle Q, because that's the only angle that's happening there. Whereas over here, I can't just call this angle U, because there's two different angles that are happening. That's why I had to use the three letters. Okay, so be careful with that. I'm very, very picky. Alright, so would you agree that angle Q and QUA are same side interior? Yeah. And what is same side interior angles?
180.
Right, they're supplementary, which means they add it to be 180. So I could have said then next that measure of angle QUA is 90 by definition of right angles. Then I could have said that angle Q and QUA are supplementary by same side interior angles theorem. And I could have said they add up to be 180 and then substituted my 90 and then solved and then said that it was 90, which means it's a right angle, which means it's perpendicular. You could have gone that route. As it sounds, it probably would have taken about 6 more steps, right? So we could have done that, but we can also skip all of that with our perpendicular transversal theorem. Questions on that? That theorem is helpful for us. Okay, let's take a look at our next one. Do you guys have a diagram for example 5?
Yes.
Good.
Yeah.
I had to copy and paste. Okay. Here it says given measure of angle 1 and measure of angle 2 add up to be 180. Prove that B is parallel to C. Looking at my picture and the given information, do I have any parallel lines to start out with?
Yeah.
Not that we
Oh, no.
Not that we know. We're trying to show it. Okay. So let's go ahead and start with this. Measure of angle 1 plus measure of angle 2 equals 180. That's given to me. And we're trying to show that B and C are parallel. Now we do have a couple of ways we can get there. So they didn't give us congruencies. They didn't give us supplementary. They just told us our measures add to 180. And it says that we're trying to show that B and C are parallel. So we want to pick numbers along that transversal, some type of relationship there. Take a look at this. What do you think we should do next? We've got a couple of options. Lucy? Good. Do you guys agree angle 1 is congruent to angle 3?
Yeah.
Why?
Vertical
Because
angle.
they're vertical and vertical.
Vertical angles, theorem. The theorem tells me they're congruent. Alright, good. So I've got 1 and 3 are congruent. Okay. What are your thoughts of what we can do next? Six.
3 and 2 equals 180.
Okay. Now I like that idea, but right now we only have the angle 3. I need to talk about measure of angle 3. So we could convert it to measure of angle 1 is equal to measure of angle 3. Or we could convert this to say angle 1 and angle 2 are supplementary. You can go either route. I'm going to give you a heads up. This route is, I think, maybe one step faster. Okay? So you can either choose to convert this to measures and then do some substituting fancy stuff, or convert this to just the angles and then do some fancy substituting. Okay? So I'm going to go with converting the first step. So angle 1 and angle 2 are what? Are supplementary. How did I know that? Just definition of supplementary angles. Measure 2 angles whose measure have to be 180 are supplementary. Okay. Now what can we do with this?
Makes 1 and 3.
Yeah, let's just go ahead and replace angle 3 and for angle 1. So I have an angle 3 and angle 2 are supplementary. And that's just substitution. And we were allowed to substitute that because we're replacing angle with angle, not measures there. And that's just substitution, not transitive. Okay. So, yippee-ki-yay, yay, angle 3 and 2 are supplementary. But what good does that do me? Come on.
You could say that B is parallel to C because of the converse of same side angles here.
Good. Same side interior angles is what 3 and 2 are. And since they are supplementary, then we can go and say the lines are parallel. Good. So now we can go with our punch line. B is parallel to C. And that is because same side interior angles are supplementary. So converse, we're proving lines parallel. So converse of same side interior angles theorem. Probably the longest of all. Alright, questions on that one? Now we didn't get a chance to start worksheet 6 in class today, so we'll probably do more with that next class. Your homework is worksheet 5. And notice what's happening next class. Quiz. That's already quiz.
I just took one.
Alright, so you have a quiz over these new theorems with lines being parallel and perpendicular, including that perpendicular transversal theorem, as well as our algebraic way of knowing if lines are parallel or perpendicular.
We're going to get our
philosophy. We now have everyone sing. So like same slow opposites. Yes, you will have proofs on your quiz. Your quiz is over. We did last class on today. So there's theorems and postulates, as well as algebra and proofs. Alright, you can go and head out to lunch, guys. Have a good day. Yes.
Can I come here and do it